we'll get started. Good morning. And I thought maybe I'll just talk very briefly, once again, about Friday's exam. Okay. Friday's test. So again, it's all multiple choice. There are a few conceptual definition questions, but I'd say larger emphasis on calculations. Covers chapters 5, 6, and the first half of 7. There's no confidence intervals on the exam, but definitely sampling distributions and checking the conditions for sampling distributions. My recommendations. Review the lecture notes and the examples covered in lecture. And then review your return quizzes. And if you don't get quiz 3 back, you at least have the practice quiz, right? So, or practice quiz 3. And then I'd say in this order, right? 1, 2, 3 would be homework, and 4 would be the textbook. Okay, 45 minutes, so we'll get started at 9 and give me a couple minutes to pass out the exams, and then we'll end probably just like a minute or two before the end of class. So, okay, any questions? No? All right. Okay. Well then great. We'll continue on with our content. We're still talking confidence intervals, and so let's try a problem out here. Okay, so let's say you are curious about, I don't know, what proportion of people, eat, oatmeal on some regular basis, on a, regular basis. We'll say, over once a week or more. I'm completely making numbers up here, all right? So I have no idea. So how many people eat oatmeal at least once a week or more? And let's say you survey, 550 people, and we'll say 350 eat oatmeal 1 time or more per week. Okay, so we will say make a 90% confidence interval for the proportion in the population. eat oatmeal. All right, here are your answer choices. We'll say 0. Okay, so go ahead and work on that. I hope the correct answer choice is available. I'll just double check them. Did these beforehand, so we'll see. So we'll let the clicker run. Again, as always, you can always talk to your neighbor during these clicker questions. Help each other out. And I'm gonna get this running. Okay, now let this run for a little bit. I'm gonna pause the video. Okay, I'm gonna go ahead and click stop here, and let's take a look. Okay, yeah. So for the most part, you guys got that, and so I'll just quickly run through how we go about getting this answer. So first, we start off by finding p hat, and p hat is going to be 350 divided by 550, and that gives me a proportion of 0.6364 if I round to 4 decimal places. My standard error is going to be the square root of p hat times 1 minus p hat divided by n. So here I have the square root of 0.6364 times 1 minus 0.6364 divided by 550. And when I do that calculation, I get 0.0205 for my standard error, if I round to 4 decimal places. And the last thing we need is our critical value z star. So for 90%, what is the z star that I use? 1.645, right? I believe I gave you a list of 4 values that I said these are kind of the 4 most common z star values. Yeah, I mean, the other way we could have looked this up is we could have drawn a normal curve and said if I want 90% in the middle, then that means I need 5% over here and 5% over here. And the z that corresponds to giving 5% is going to be negative 1.645 plus or minus 1.645. Okay, so I put all of these together into p hat plus or minus z star times our standard error, and I get 0.6364 plus or minus 1.645 times 0.0205. 1.645 times 0.0205 gives me plus or minus 0.0337. And so when I do all of this, I get 0.603 to 0.670, and this is if I round off to 3 decimal places. So there is my confidence interval right there. Is that good with everybody? Okay. Alright, so I'm going to go ahead and copy this onto the next slide, and let's talk about the interpretations that we can make based on this confidence interval. So what I can say is something like I am 90% confident that the proportion of people who eat, say, oatmeal regularly, this is probably too high, but regularly is between 0.603 and 0.670, okay? Or, we can say just, so if you say our 90% confidence interval goes from 0.603 to 0.670. This is what we have. So this is our interpretation. I am 90% confident that the proportion of people who eat oatmeal regularly is between 0.603 and 0.670. Okay? And so I can ask, so here we'll have a question. Do we have evidence that the proportion is not 0.68? Okay, here we'll just do yes versus no. Do we have evidence that the proportion is not 0.68? Okay, you can talk to your neighbor. Okay, we'll close our poll here in just a couple seconds. I'm going to go ahead and click stop. Okay, and let's take a look at how you responded. The correct answer is yes, A. Okay, do we have evidence that the proportion is not 0.68? The answer is yes, because what? 0.68 is not inside our interval. Okay, so at this point, based on our interval, we are confident, based on our interval, which is based on the data or the evidence, right? So based on our interval, we are confident that P is not equal to, P is not 0.68. Yes, question?
Given that we're only 90% confident, how can we say that for sure? And how is that different than what was proposed in the last class?
I didn't say for sure. I just said, do we have evidence that the proportion is not 60?
Because if you said that we have evidence that the proportion is likely not 0.68, I see where this is coming from, but to say for certain that it's not 0.68.
Okay. All right. I understand your argument here, and but I never said. Does this prove that the proportion is not 68%? I don't know. Maybe we're mincing words here.
Because like this question, it sounds to us like is it proof that it is not?
But you're adding words to what I have written up there. I never asked, does it prove that the proportion is not 68%? Okay? But does evidence prove anything? Like when you go to have a jury, right? Let's say there's a criminal trial and the thing provides, like the prosecution makes a strong case, yeah? Okay? And they have all this evidence. Here's the murder weapon, here's the fingerprints, here's the DNA, all of this, right? Does that prove that the person is guilty?
Am I 90% confident that their evidence is legitimate?
No, it's you'd say, okay, if the jury concludes guilty, yeah, you'd say, okay, well, there was enough evidence to say guilty, right? There's enough evidence. But a jury conviction doesn't prove what happened in the past, okay? And that's what we're saying here. Do we have evidence? The data is coming, okay? And we're creating a 90% confidence interval. Do we have evidence that the proportion is not 68%? I don't know. Do we have evidence, I guess, based on our confidence interval? I don't know what you want me to say here. Do you have evidence that the proportion is not 68%? And we would say yes, okay? I'm going to do the other example here, and you guys are going to get angry with me. But I guess it's to drive home a certain point, and I guess my only consolation is for those of you who got it wrong, this is like one clicker point in like the grand scheme of the entire course, okay? And let this be a learning opportunity over, I guess the semantics of our phrasing here. Okay, so I got 68% is not inside our interval, so based on our interval, which is based on the data or evidence, we are confident that P is not 68%. This, but if we want to ask, does our confidence interval prove that P is not 0.68? The answer is going to be no. All right? Our confidence interval can't prove anything. What's the only way you can prove that P is not 0.68? The only way we can prove that P is not 68% or that P is anything is to observe the entire population. We have to interview every single person in the population, I don't know, make sure that they're telling us the truth about their oatmeal eating habits, and then calculate a proportion, and that's the only way we would get an exact value for P, and then we can say, I know the exact value of P, and I know it is not 68%. I can prove that proves it. Yes, question? I'm sorry?
Does that suggest like we are confident does not mean that it's not that it's not. But what percentage do we have to what percentage of the confidence interval?
Yeah, what percentage, like you guys aren't comfortable with 90% confidence. Yeah, this is a good question. Here, let me just do another example here, okay? Let's say instead of a 90% confidence interval, we decided to make a 99% confidence interval. Okay, so let me just kind of flip back in our notes, all right? This is the calculations we did for the confidence interval. I'm going to go ahead and copy this. Now, if I switch from 90% to 99%, what changes? My p-hat remains the same, my standard error remains the same. The only part that changes is this 1.645 changes to the number we use for 99%. Okay, that's the only part that changes. So let's go ahead and do that. Okay, so now we're going to make, using the same data, 99% confidence. Same data, make a 99% confidence interval. So instead our z is 2.58. So I plug in 2.58 times 0.0205. And now I have plus or minus 0.0529, okay? And I go plus 0.6364. And we get 6893, and then 0.6364 minus 0.0529. Go 0.5835. 0.5835 to 0.6893. Okay, and then I know some of you are saying, see, this is what I'm talking about, but it's all right. So now my 99% confidence interval, this is my 99% confidence interval. And then if I ask the same question, do we have evidence that P is not 68%? Our answer here is now no, okay? Do we have evidence that P is not 68%? Our answer here is now no, and that is because 0.68 is inside the interval. So it is now considered, so it is a plausible value of P. Okay, so let's just kind of flip back. We used the same data, and over here we said, do we have evidence that the proportion is not 68%? And we answered, oh, I forgot to circle yes. Over here we said yes, 68% is not inside our interval. Based on our interval, we are confident that P is not 68%. Okay, over here, same data, we make a 99% confidence interval, and we ask the same question. Do we have evidence that the proportion is not 68%? And this time we say 68% is inside the interval, so it is a plausible value of P, and therefore we have to say we do not have evidence that P is not 68%, okay? So we don't have evidence that P isn't 68%. I know it's all these double negatives. So what's the difference here? Okay, well, over here, the difference, in both cases we have the same data, we use the same data, but we change the level of confidence. Okay, and what this is, you know, if you have to be extra confident in your answer, then that means you're going to be less willing to reject certain values, okay? If you're okay with 90% confidence, and someone says, do you think it's 68%? At 90% confidence, you can say, no, I don't think it's going to be 68%. However, someone says, you know, I'm not cool with 90% confidence. I want you to be 99% confident in the answers you're giving me. Then you have to say, okay, well, 68%, maybe it could be that, right? Imagine planning for a party, okay? You send out all these invitations, okay, but you know, people are rude, they don't send back their RSVPs, and so now you don't know how many people are coming, right? And so you can say, okay, well, you know, you're going through your list and you're like, this person probably will come, probably won't come, and you go through, you say, okay, I think if I get enough, if I buy food for 20 people, that's going to be enough. How confident are you? I'm 90% confident that food for 20 people is enough, okay? I want you to be 99% confident that we have enough food, Okay? If someone says, I want you to be 99% confident in the amount of food you get, then you have to kind of expand that, right? You'll probably say, okay, well, I probably need to buy enough food for 30 people or something because of all these people that didn't respond or something like that, right? And then if someone says, I want you to be 100% confident we have enough food, then you have to buy enough food for, just in case everybody shows up, for everybody who, you've sent an invitation to or something like that, okay? It's the same kind of idea here. Based on your level of confidence. If you have a lower level of confidence, you can get away with a narrower interval, right? You can get away with buying less food and having less waste and things like that. But if you want to be absolutely sure that you got enough, that you're getting the P, and actually absolutely sure is not the right term. If you want to be more confident, then you've got to allow for these values on the outside, okay? So we use the data, we change the level of confidence, okay? A higher level of confidence means that more values are now plausible. Values of P. Okay, so, or in other words, higher confidence leads to wider intervals. Okay, is that okay? We'll have another one of these true-false questions here, or yes-no questions. Okay. So let's go back to our 90% confidence interval. Copy this. Okay, so this is what we said. This part is true, okay? This is true. So here's the question. So I wrote, I am 90% confident that the proportion of people who eat oatmeal regularly is between 0.603 and 0.670. And so now the question is, here's true, false. True will be A and false will be B. True, false. There is a 90% probability that the proportion of people who eat oatmeal regularly is between 0.603 and 0.670. True or false? There's a 90% probability that the proportion of people who eat oatmeal regularly is between 0.603 and 0.670. So go ahead. You can talk to your neighbors about this. Let me know, hit pause here. All right, I'm going to go ahead and click stop here. All right, let's take a look at our answers. Okay. And the correct answer is it's B. It's false. Oh, okay. This is everyone's angry. It's just clicker points, all right? I'm exposing you guys to tough questions now so that in the future when you see an exam question, you'll be prepared. All right, why is this false? Okay, why is this false? Okay, what's going on here? Okay, let's, I've got a coin here. I'm borrowing a coin. I've got a penny, all right, and I'm going to flip this penny. I'm going to say, what is the probability, okay, when I flip the coin, what's the probability that it lands heads? Not a trick question. You tell me. You're supposed to say 0.5, right? 1/2, okay? Okay, so what's the probability that it will land heads? You say 0.5. Okay, so now I flip the coin, okay? And so the question, I'm going to ask the same question. What is the well, a little different. What is the probability that the coin has landed heads? Okay, so what is the probability that the coin has landed heads? Okay, now watch what I do. All right. What is the probability that the coin has landed heads? Okay, so I'm looking at the coin now. All right, what's the probability that the coin has landed heads? That's my question. Okay, you guys are just totally weirded out by this example here. Okay, the truth is that the last two questions were nonsense questions. Once the coin has landed, there's no more probability. It no longer makes sense to ask about the probability that the coin has landed heads, because the coin either did land heads or it did not land heads. There's no probability associated with it. There's no uncertainty, there's no probability. You don't know what happened, but we can't talk about the probability of something that is determined and has happened in the past. Okay? So now that even though you don't know what the coin is, because it's determined, now all you can say is, I am 50% confident that the coin has landed heads. Okay, so you can talk about, I'm 50% confident that the coin has landed heads, but you cannot say there's a 50% probability that the coin landed heads. Okay, before I flip the coin, it makes sense to talk about probability, because it's something that will happen in the future. There's uncertainty about it. Once it has happened in the past, or once it's a determined thing, there's no more probability. It no longer makes sense to talk about probability. It landed heads, by the way. And thank you for letting me use your coin. So what we have here is, it does not make sense to talk about the probability that the proportion of people who eat oatmeal regularly is between this and this, because the population proportion is a fixed value. Okay, if I wanted to, I could freeze time. I can't do this, but if I could freeze time, I could count every single person, and I could count every single person who eats oatmeal regularly, and we can get the exact value of p. All right, we can get the exact value of p. There's no uncertainty about this population proportion. We could, theoretically, we could find an exact value of p. Okay, and there's no uncertainty. Associated with it. So it does not make sense, so we cannot talk about probability. Probability of p. We can only talk about our confidence about what p is, okay? Because p is unknown to us, we can only talk about the probability of p. Okay, so what exactly does it mean to be 90% confident or 95% confident? If we're not talking about probability, what does it mean to be 90% confident? Okay, so okay. Well, the idea is, okay, think back to the sampling distribution. Okay, so here's we could pretend that this is a bucket of people, and we're going to get a scoop, and we're going to see, how many people eat oatmeal or whatever, okay? But we'll just do M&Ms, okay, or whatever, okay? So let's say in the population, p is equal to some value 0.65. Let's say this is the true value in the population. What we're saying is that when I take a random sample, okay, there is a 90% probability, and a 90% probability that the resulting sample produces a p hat close enough to p that the confidence interval will be, quote unquote, correct. Right. So what we're saying is that when I take a random scoop, there's a 90% probability that this random sample gives me a p hat, like 0.67 or 0.64 or something close enough to the true value of p that when I make my resulting confidence interval, that confidence interval will have the actual value of p inside of it. Okay? Will be correct, meaning the confidence interval does contain the true value of p. When we are dealing with a sample, though, okay, the reason why we have to talk about confidence intervals, yes, question?
Sorry, I was going to ask, is it inclusive, the confidence interval? Oh, like,
Yes. Generally, if we do the full calculation, there's like hundreds of decimal places, and it doesn't really matter, okay? So, but yeah. So, when we're doing a confidence interval, however, we're not going to take a random sample. We've already taken a random sample, okay? So we've already taken a sample, and there's already a fixed value p in the population, okay? So there's no more. So here is, when I will take a random sample, there's a 90% probability. When we're looking at data, the sample has already been taken. So the coin, we can think of the coin has already landed, okay? So, when we look at our data, the random sample has already been taken. So there's no more probability that we can talk about. Okay, so no more probability. So that's why we're talking about confidence. No more probability. P is a fixed value, no probability there. We can only talk about our confidence about the resulting interval. And so the idea here is that when I've taken a random sample, and it's already here, I'm 90% confident that this thing has the true value of P. But if I could go back in time to a step before I've taken the random sample, the reason why I can be 90% confident in the future is because when I take a random sample, there is a 90% probability that my resulting sample will give a p hat close enough to p that the confidence interval works out. Okay? But of course, when we're dealing with data, the data has already been taken, so there's no more probability there. Okay? It's just if I could go back kind of like 2 steps in time, then before I take the sample, it does make sense to say there is a 90% probability of it working out. Yes.
Before you take the example, how would you know?
You don't. I mean, what's that?
If it's before you take the example, how do you know the length?
You don't know. That's the whole thing about probabilities. You don't know what's going to happen in the future, right? But I can say there's a 50% probability that the coin will land heads. I don't know how it's going to land, but it makes sense to say there's a 50% probability it will land heads. When I
They only get the conclusion of the 90% out of what we
No, the 90% probability is based on the central limit theorem, which says that whenever you take a random value, it follows the normal distribution. And we know that things coming from a normal distribution, 90% of the time is within 1.645 standard deviations of the mean. That's where the 90% is coming from. Okay. All right. We'll end here. We'll see you guys on Friday. Good luck as you guys study. And we'll see you then.